Okay, in this lesson, we're going to be working with one-step inequalities that involve multiplying and dividing. Very similar to what we worked with in our previous section where we reviewed adding and subtracting with inequalities. We're still going to use those inverse operations. So we're going to remember when we see multiplication, we want to use division to isolate that variable. And when we see division, we're going to be working with multiplication in most circumstances. Okay, so let's go ahead and start off right away. I don't think we really need to review how to solve a one-step equation. Just because of the practices from yesterday, I think it's going to kind of remind us of working that multiplying and dividing, and we'll get plenty of practice here. Okay, so here I have negative 15 is less than 2.5q. So we have to remember that when we have a number right next to a letter, that this is involving multiplication. Now, just as we did in our previous lesson, we have to make sure that if we're not comfortable having that q on the backside, that if we choose to rewrite this, that when we flip it around and we put the 2.5q in front, that we also flip around this symbol. Okay, it still has to be eating that bigger number. Notice how the open mouth is pointing towards the 2.5 in both situations now. Okay, so if you choose to rewrite it, make sure that you're also flipping the symbol around. I'm going to go ahead and work off of the original equation. Those of you that prefer to see the variable on the left side, you can use the one that I have sitting over there in red. So now if I want to work to get q by itself, right now it's multiplying. I'm going to go ahead and divide by 2.5 to get q by itself. So I'm going to divide by 2.5. Yes, you may use a calculator. Please feel free to use the calculator. If you want to do it longhand, that's perfectly fine, but I'm not checking your computation skills. So if I know when I do this, I'm going to be getting a negative number because I count negatives when I multiply and divide. So I'm not going to punch it in as negative 15. If I choose to use my calculator, I'm just going to do 15 divided by 2.5. And just know that my answer is going to be negative. So when I do that, I get negative 6, my symbol, and then my q is still sitting on the right side. Okay, so now I'm going to go to negative 6 on my number line. Type of symbol tells me it's going to be an open circle on negative 6. And then q is being eaten, so it's the bigger number. Negative 6 is smaller. Bigger numbers fall to the right. Okay, so we could include negative 5 all the way infinitely to the right, and it would be a true statement. 6 would not be included in that because it was not also equal to. Okay, so let's go ahead and try another one here. Got another one with multiplication. So right now I have 4 times b is greater than or equal to 2. Okay, so this is like where our equal sign is normally. So I want to get the b by itself, so I'm going to divide by 4. Divide by 4, so I get b is greater than or equal to 2 divided by 4, which we can either work it as a fraction or a decimal. So 2 divided by 4 would give me 0.5 if I want to see it as a decimal. If I'd like to see it as a fraction, I could just reduce that down to 1/2. Okay, so I'm going to go ahead and pull my other graph out here since that was an integer graph. I'm going to pull this blank one out so that I can actually do some rational numbers, which would include fractions and decimal numbers. Okay, so I'll go ahead and just I'll use the decimal. Okay, throw a few numbers in there. So looking at my symbol, well, it's got the line underneath, so I'm going to color it in on 0.5. Or if I choose, I could use 1/2. Okay, and then I could go through and make some other fractions up, like maybe 3/4. Maybe down here it would be 1/4. Whatever you're comfortable with using, okay? Decimals to me are just easier, but sometimes you're expected to use the fraction, so you have to be comfortable either way. Okay, so now I have to decide what direction my arrow is going to go. So b is the bigger number. It's getting eaten. Bigger numbers are going to fall to the right. So there's my graph. If I was using the fraction, same thing. I'm still going to fall to the right. All right. So you're not always going to get whole number answers on these. Sometimes you get fractions. Okay, so let's try this one. I had DJ, or D, my goodness, 5J. So they're right next to each other, means I'm multiplying. So I want to get J by itself. I'm going to divide by 5. To cancel it out, and then I go to the other side of my inequality here and I divide by 5. So I have J left over, my symbol. 20 divided by 5 gives me 4. So I'm just going to keep this graph out here and throw some numbers in there. And 4 is the number I'm going to mark on. Line underneath tells me filled in circle. Now I have to decide the direction of my arrow. So J is being eaten. It's greater than or bigger than. So bigger numbers fall to the right. Okay, so that's working some with multiplication. Let's try a few with division. And division is the one that I would say when we assessed, some of you would get confused on with the division. So just remember, you're looking at that m over 10 and you're thinking, that's dividing, I need to do the opposite. Okay, so if you don't like how this looks, I'm going to shift this over and I'm going to rewrite it. You have to be comfortable with rewriting it. So I like to have the variable on this left side. Remember, when we flip-flop, we have to also flip-flop the symbol so that this open mouth is still eating the side that has the m involved, right? And then I have a negative 0.5. Okay, so now you can work it either way. Doesn't matter. I'm going to go ahead and work the one off that original. Just to show you, it's not going to matter which side your variable's on. So to get m by itself right now, it's divided by 10. I'm going to go times 10, which is the same as 10 over 1. Okay, but I'm not showing that over 1, but I'm going to go ahead and go times 10 here. Now, you may go ahead and use your calculator if you need to, but really taking anything times 10 is moving your decimal over one place to the right. So this is going to give me 5, and there was one negative, so it would be a negative 5, my symbol, and my letter that's left over. Okay, so I'm going to go ahead and do my number line. So we'll do negative 5 in the middle. Now, key thing is, remember, when you're working negative numbers, they move in the opposite direction. So no, I do not put negative 6 over here. Okay, that is negative 4, negative 3, negative 2, negative 1. Remember, because you're working your way towards 0. And then this would be the side that has negative 6. I would say that's a very common mistake that gets made when we're setting up number lines, as we forget the order. Okay, negative numbers work in the opposite order because that negative is opposite. Okay, so I am going to my 5, and the symbol has a line underneath, so it's a colored in symbol or circle. Larger number, m is the larger number, so larger numbers always fall to the right. Remember, with negative numbers, yes, the digits become smaller, but they're really worth more because they're closer to 0. All right, let's try another one of those. Okay, so we have x divided by 2 is less than or equal to 3. So here's our symbol. So this one's just set up differently, but we're still going to show that times 2 to cancel this out. It's really giving us 2 times 2. It's not really doing 2 times 2. It's taking that whole equation and multiplying it by 2, so it's canceling out that divided by 2. So I would go times 2. So I've got x, my symbol, and 3 times 2 is 6. So I'm going to throw my 6 on there. And my circle goes on 6, and it's going to be colored in because we have the line underneath. And 6 is the bigger number, so x is smaller. X is going to fall to this side of our circle. Let's try one more of those, and then we're going to work some rational numbers, just so we can practice setting up our number line, basically. Okay, so we have p divided by 7 is greater than 2. So we're going to do a times 7 to get rid of it. Times 7, so we get p is greater than 2 times 7 is 14. So we're going to throw a 14 on there. Okay, open circle. because there's no line underneath. P is being eaten, it's bigger. Bigger numbers fall to the right. All right, let's practice a couple rational numbers. Okay, so rational numbers meaning sometimes we're either going to get decimals or fraction answers. Okay, so when I look at this, still following that same concept, I want to get that a by itself, so I'm going to divide by the -2 to get that with it. Don't forget to take the negative with the 2. Okay, so now I have a is greater than -9 divided by -2. Well, 2 negatives make it a positive. 9 divided by 2 is 4.5. So you could either use 4.5 or you could use 4.5. So I'm going to put 4.5 in the middle here, and then I'm going to put a couple numbers on each side. So maybe this is 4.6, and this is 4.3. And I could continue it, but I need to make sure that I'm giving some numbers on there. Okay, so open circle because it does not equal 2 on the 4.5. And A is bigger. A is being eaten. Bigger numbers would fall to the right. Okay, still working those same concepts. Just I wanted you to understand that you're not always going to get whole numbers. Sometimes you do get fractions or decimals. Okay, so I have -12 is greater than or equal to 6/5 times m. Okay, so 2 ways that you can work this one out. First of all, if you don't like the m on the right side, you're going to have to rewrite that. I'm going to go ahead and work it the way that I see it. You could choose to change that 6/5 into a decimal. So I would do 6 divided by 5. It gives me 1.2. So if you would prefer the decimal form, you could do that. -12 is greater than or equal to 1.2 m. So some of you might prefer to take that extra step. I'm going to go ahead and work it as a fraction. Either way, we're going to end up with the same answer. We should end up with the same solution. So if I wanted to get rid of that times 6/5, I would divide by 6/5 to cancel it out. Now, here's what I have to remember. When I divide by 6/5, remember with division of fractions, you keep, you change, you flip. So I would keep -12/1. I would change to multiplying, and I would flip this fraction to 5/6. Okay, so now I like to cross cancel. 1, 2. So now when I multiply, -2 times 5 would give me -10/1. So I just found out that when I redid this, m, and then my symbol was like this, and I just got -10 for this. Okay, I'm going to graph this equation. So -10, remember setting up our negative number line, we work in the opposite direction. So 11 is going to be back here. This would be 9 and 8. So -10 is the bigger number, and it does have a line underneath, so coloring in. So smaller numbers, remember, you're working negatives. Smaller numbers always fall to the left, whether it's positive or negative. Even though those digits with that negative sign get bigger, they're actually worth less. Okay, had I worked it off the decimal form, you would still get, whoops, that's a 1.2. You would still get 10 for that side. So you have to decide what you're most comfortable with. I would guess most of you would probably prefer the decimal form, but it doesn't always work to convert it to a decimal. Sometimes we get those repeating decimals and they're hard to work with. Let's try one more of those. Okay, so we have -4.2 is greater than or equal to -0.7 times w. So I'm going to leave it in the order it is, and I'm going to divide by -0.7, taking the negative with it. Okay, so now I have w left on the right side. My symbol stays the same because I chose to keep it. And 4.2 divided by 0.7 is going to give me a 6. Okay, so now I had 2 negatives, so it's a positive 6. Okay, so 6 is my number that I'm graphing on. And it's going to be a filled in circle. And 6 is the bigger number, so W is smaller. It's going to fold this way. Okay, So that's it for one-step inequalities with multiplying and dividing. Key thing to remember on this, you're always going to work the opposite or the inverse operation. Still working to get that variable by itself on one side of the inequality symbol. Remember, with your symbols, they help to determine whether your circle is going to be filled in or open. And then make sure that you're paying attention to the direction of your arrow.